Today we're going to relearn how to calculate the sum of vectors using component method and law of cosines. To start with component method, we're going to examine the 90-degree angle or right triangle. This previous information given with the horizontal and vertical components are shown. So on the y-axis you have v sine x, and on the x you have v cosine x. And this is all to find the resultant vector, vector v. So just a quick reminder of how to do it. We're going to apply it. So here's your right triangle. And so you just plug in 5 cosine 30 because that is on the x-axis and it's the horizontal component, and then 7 sine 30, which is the y or the vertical. And you take the angle of the resultant vector. So we calculate it, and it comes out to Vx equals 4.3 and Vy equals 6.06. And then you use the Pythagorean theorem to figure out the resultant vector, which will be 7.45. So, now that we know how to do that, and now that we have the component method, vertical and horizontal, and equations in our head, we also need to know that the vectors must be arranged from head to tail. So, when given a vector A and a vector B at certain angles, so our goal would be A plus B if A is 60 degrees and B is 30 degrees, and then A is 4 and B is 3. So we're given this and we assume that that is our resultant vector, but that is incorrect because the vectors are not arranged head to tail. So in another case in the same case we're given vector A and vector B, and this time we're going to put B at the head of at the tail of vector A. And this is how we get our resultant vector. This is correct. So calculating from head to tail in a scalene triangle is different than calculating at a 90-degree angle. So the first thing you want to ask yourself is, after you look at your goal, where can I find the 90-degree angles? And in the image they're shown. So you can assume by looking at your goal and looking at vector A that the vertical component of vector A is 4 sine 60. And the horizontal component is 4 cosine 60. The same with vector B. 3 sine 30 and 3 cosine 30. So, the harder part comes in when we look at how to picture the getting the answer of the resultant vector. So first, remind yourself where the resultant vector is, highlighted there, and then see how the vertical components of both vector A and vector B line up to create a perfect vertical component of the resultant vector. The same goes for the horizontal. So if we take that triangle out, they're left with a nice 90-degree angle triangle. And to get the complete vertical component of the resultant vector, you're going to want to take the vertical component of B, 3 sine 30, plus the vertical component of vector A, which is 4 sine 60. That comes out to 4.96 newtons. And then you do the same for the horizontal. And then you do the Pythagorean theorem, which gives you your answer of 6.764 newtons as your resultant vector. So the vector direction is another part of calculating the sum. So we want to look at our components again, and we already know that y equals 4.96 and x equals 4.6 because of our previous equation. So we want to ask ourselves at what angle is the vector, which is right there. So we like to use tan to the -1 or inverse tan. And we do y over x, or opposite over adjacent, to calculate the angle of the vector. And the vector is at an angle of 47.15 degrees. How to calculate sum of vectors using law of cosine. So using law of cosines, we're going to use the same triangle as we did in the component method, and keep in mind that it's still head to tail arrangement. We already know the equation for law of cosines, and we already know our goal. So we can assume, well, we know that vector A is 60 degrees, vector B is 30 degrees, and C, and we know that vector C is there. And we also know that 60 degrees is an interior angle with angle C. So we can assume that this angle is 120 degrees because 180 minus 60 is 120. And interior angles add up to 180. So that being said, we know angle C is 150 degrees because 30 plus 120 is 150. So all now you have to do is plug it in. We do our algebra, we write the things down that we know. We're looking for resultant vector C. So we're plugging it in, and you get 4 squared plus 3 squared minus 2 times 4 times 3 cosine 150. Now if you look at that, make sure that everything's matching up. We're calculating, and we get c squared equals 45.78. So the square root of that number is 6.76, which, as you'll notice, is the same answer we received using the component method. Just as effective. And we remember our goal, always. So, the vector direction, let's remember our angles and our sides that are now known. So, we're now looking for angle B because it is opposite of side B. So look at side B, and the angle across from it is the angle we are trying to find. So now we use law of sine. Sine of 150 over 6.76 equals sine of B over 3. Sine of 150 is angle C, and 6.76 is side C. So it's going to be sine of angle C over C. And sine of B is over side B. And so we cross multiply as we calculate, and we get B equals 12.82. If you need guidance on how to do law of sines, it's on the wiki. So we calculated it, and we got B equals 12.82. So we know that the vector A is 60 degrees in total. So we can subtract the 12.82 to get our answer of 47.18 degrees. keep in mind that the angle 12.82 is the acute angle of the entire triangle ABC. So subtracting 12.82 from 60 would give you the leftover angle of vector C. So, if you need help or any extra guidance, look at the book. It offers practice problems in Chapter 8, and the website provided on the wiki describes the component method, which is also the website that was given to us by Mr. Matesser on the class website.